Okay, I'm going to try and narrate some slides so that you can build our MPPT controller module. It looks like this on the back and that on the front. So I hope that makes sense to you. Obviously this is missing from the slides, so hopefully you can you'll know what to do anyway. So there are 16 slides in total, and I'm going to go narrate them for you so that you know exactly. First thing you want is an Arduino Nano. This should be simple and straightforward to get hold of. A 360 mini buck converter that you will save to 5 volts, so make sure you set that before attaching it to anything. You will need a little block connector to put auxiliary power in. We're going to use 12 volts here. That goes to the little mini buck converter, and it will also go to the outside of the opticoupler. So you'll need 4 resistors, 2 7s and 2 1s. These will be your voltage dividers, so you can read your solar voltage and your battery voltage. Then you'll need your octocouplers and some ASC 758s to read the current. So you should end up with something like this. There's your SDA and SLC for your display. I'm using a 24 or 2004. So you connect up your opticoupler to the 12 volts, and then obviously you put the resistors in for the gate, and then the gate actually goes to the MOSFET drivers on the buck mod. So then connect up the couplers then for the current readers from the AC voltage, from the 12 volts, no you don't, connect it to the current readers to the 5 volt rail, and then back out to the corresponding pins. So I'm going to read out what the pins are for you. I think we've stopped on the slides now. So A0 is your solar current, A1 is your solar voltage, A2 is your battery voltage, A3 is your battery current, A4 is the SDA, A6 is the SCL. Your 5 volts is attached to the Mini 360, and so is the ground. D2 has a resistor and a LED attached to D2. D10 is attached to the opticoupler for the PWM signal. So the current sensors are ASC 758 100 amps because I have a high current system. You can use different ones, the 752, but I find the connections on them really small, and if I was wise enough I would have actually picked up one and brought it up. But we're using a separate board for the current sensing because it's such a high current, and then it's just obviously it's just fed back. So just make sure that you have your 12 volts coming in. I've used an auxiliary battery which I charge straight from my solar every now and again. It's 1000 watts, so it lasts forever. The 12 volts is needed on the opticoupler at gate, or whatever you want to call it, because the MOSFETs that we're using, while they are logic level, according to the data sheet, they use up to 12 volts to really pump the current through, and that should be fine for the current that I'm using. I've got about a 36 amp current, so I'm 1 amp, 1 volt basically. So this is how you would set it up, and obviously you'll find on the blog the code for it. Now we've put on the basic code to it. We're on firmware revision 2.1 currently. By the end of the week I expect we're up to firmware 2.2. It's only because I want to refine the MPPT function more so on there, and I don't know if I put my LED for the status in the wrong way. I think I have, but it does read and display on the screen, and I'll show you it now actually. Maybe I won't because I don't. So back with the cable, and I brought out the current sensor. There we go. So this should show up. So as you can see on here, the E, hang on, let me try and, right, so you've got your solar voltage, battery voltage, the current coming from the solar. Obviously it says the status is the solar's low power. PWM's at 0. Wattage is obviously none. So you've gone into bulk mode. And this is the calculations for the efficiency of the PWM. My ASCs is I've wired them so they're in parallel on the power, and the output pins correspond. So there's a 4-pin header here, and so you got your 5 volts and ground, and then sensor 1 and sensor 2 respectively, and that goes back into the controller board. So these come with tiny little block connectors on there. You could put probably a 50 amp screw terminal on there. However, if you get some sandpaper, you can sand these off. These have got big copper pads on there, and then you can solder some big fat wires on there. The firmware is on the blog, so I don't even know the best way to actually get there. We're in the middle of designing our website, so what we've got is our a holding website currently at renewsolar.co.uk. There should be some links off there where we've got a WordPress blog, and if you go into the blog section of that, it should display up Solar MPPT Controller, and that will give the code that you would want to start running this. So there is some adjustment parts in there. It's all explained on the blog anyway, to adjust the coding relative to your sensor. So if you've got the other sensors, which I did say I would bring it up, but I didn't. If you've got the other current sensors, you need to change that in the code and such like. So I hope you enjoyed the video. If you want to find out more or interested in solar, do subscribe and click on the playlist link on the channel for the solar and off-grid, and that'll give you all your solar information. So I don't think we're going to do any more development hardware wise on this. It doesn't actually need any more. Obviously it's modular, so you should find our buck converter side of this, the module that goes with this to make it into a MPPT solar charger. Thank you, goodbye.